Welcome, everyone. Thank you for attending. I'm going to be giving away this book, my latest book, Domain-Driven Design Distilled, after my talk. So if you want to maybe hand your name to someone at the end of the row who could bring it up later so we don't interrupt the talk, welcome to do that. This is implementing microservices with Scala and Akka. And don't forget to turn in your rating of the session. Just to give you a little bit of information about myself, you can contact me by email using vaughn@forcomprehension.com and follow me on Twitter at Vaughn Vernon. And For Comprehension is both an online learning site and also I provide live training around domain-driven design and go reactive with Akka. I'm the author of Implementing Domain-Driven Design. This is a bestseller that's been out for about 3.5 years now. And I'm also the author of Reactive Messaging Patterns with the Actor Model. This is specifically a Scala and Akka book that discusses various design patterns and integration patterns that you can use for implementing applications. And it has a domain-driven design slant. And then this is my latest book, Domain-Driven Design Distilled, which I'll be giving away after this. One thing that I have noticed, I don't know about you, but we seem to be an industry of extremes. Developers seem to go from one extreme to another, and one of the extremes that I see is that ACID has to apply everywhere, ACID transactions, right? Your application must be ACID. If you integrate with other applications, we have to mimic ACID through XA or global transactions. Why is this the case? Why do we seem to think that ACID is necessary everywhere? If you actually go to the business that you work in, if this business existed or something like it existed before computers existed, you would probably find that businesses did not have consistency in their business processes ever. Their business processes worked by handing and circulating memos and work orders and so forth from one inbox to another. You could sort of say that you could mimic the same thing today using email. Imagine running a business entirely by email. Well, it's not that we recommend that you run a business by email, but in essence, that is the way businesses ran. And almost nothing was consistent before computers. So the question is, where did we get the idea that business had to be transactionally consistent all over the place at all times? Consistency is overrated because actually the business most likely doesn't need to have ACID transactions or XA in all cases. You know where to get the answer? Ask the business. How much time would be acceptable for me to allow, or our team to allow, between the consistency of this data and the consistency of this data? A few seconds? A few minutes? A few days? Sometimes consistency isn't required for many days. So why do we think that we have to build in transactional consistency everywhere? Everything used to be eventually consistent, and one of the big advantages to eventual consistency is it actually matches the business needs in many, many cases. Another extreme that we see today is in the size of a service. What is the size of a service? Should a service be a monolith? That's one extreme. Or should a service be micro or nano-sized? And if so, what is a microservice after all? What does microservice represent? Is it a number of lines of code? Or is it some other measurement? How do we measure what is the right size of a service? On the one extreme, we have the monolith, or worse than a monolith. What most applications turn into is a big ball of mud. This pattern is seen everywhere, and I do a lot of consulting. I teach at a lot of organizations, Fortune 500, Fortune 10 companies, and everywhere I go, I see the big ball of mud lurking. And everybody has to integrate with the big ball of mud, or everybody has to get their hands dirty with the big ball of mud. Nobody wants to, but why did we build it that way in the first place? I describe big ball of mud as being worse than a monolith, because at least usually a monolith that is well designed, well modeled, can be reasoned about, whereas a big ball of mud is several tangled models that are implicit instead of explicit, and the models are not well defined. And so if you go to one place to try to understand what happens here, actually if you touch this piece of code, it's going to have a ripple on something unseen in another part of this large tangled model that is implicitly maybe 5, 6, 7, 8 models actually. But what about microservices? If you are going to implement microservices, how do you go about doing that? Well, we'll talk about some general guidance that others have given about microservices, and this is one of those. What do these numbers have in common? 100, 400, 1,000. Lines of code, right? This is how many lines of code your microservice should be. And I've heard all of these. They conflict. So if I write a microservice that's 450 lines long, is it too big? If I write a microservice that's 100 lines long, does it mean it's a good microservice? Should we use 1,000 as an upper bound and say that if your microservice is more than 1,000 lines of code, it's a bad microservice, it shouldn't be out there? I actually don't know the answer to that, because I don't believe that line of code count is a good metric to use for determining what your microservice should be. Now, if you've heard of Fred George claims to be the originator of the idea of microservices. I don't know if that's true, but he claims to be. And Fred George says that actually one page of code, or he also uses the term 100 lines of code, is a good size for a microservice. One page of code. What does that even mean? What is one page of code? Does that mean 62 lines? If you use the old dot matrix printer? I really don't know. What if your lines break and, what is one page of code? Does that mean what you can see on a screen? What if my eyesight isn't as good as yours? Does that give us a good line of code count? And how many microservices actually make sense? If you're going to develop microservices, should you have thousands of microservices, hundreds of microservices, tens of thousands of microservices? Fred George actually says that in the enterprises where he works, they have so many microservices that they don't actually know which microservices are still useful. They're still deployed, they're still running, they still receive messages and act on things, but they may not mean anything to the business. What justifies that? According to his guidance, it's $40 a month to run that service in the cloud, so who cares? I don't think that that's a good measurement for a microservice. So when you start thinking about the infrastructure to run these things, the cognitive dissonance and overload that we have when we try to reason about a system with thousands and thousands of services that may not have any use to the organization any longer. They're just running because it's cheap and we can continue to run them without any impact. What do we do about that actually? What is practical? What is the good size for a microservice? And what does domain-driven design have to offer? So as an author of 2 domain-driven design books and consultant around domain-driven design, you probably imagine that I'm going to say that domain-driven design has a lot to offer, and I believe that is the case. The answer is bounded context. With domain-driven design, we have a notion of a bounded context. This is where a specific domain model has relevance, where the terms and expressions that we use in a business setting or a business context are bound within a specific area of the business, and this is what we consider to be a domain model. And it is often around what we refer to as a core domain, the thing that is most competitively advantageous for your organization to put its resource developer investment into in order to create the most beneficial payback for your company in terms of competing with other organizations. And if you're familiar with this book by Sam Newman, Building Microservices, Sam Newman talks about in his book using domain-driven design, bounded context, as the basic boundary for each microservice. Now, I think that Sam Newman has a little bit different definition of what a bounded context is. I've talked to Sam briefly through Twitter, actually. What size is a bounded context then? And Sam's answer is something like, well, it's as big as it needs to be, and when it starts to feel like it's getting to be too big, then you need a new bounded context. And I think that that is actually not a good answer for what is the size of a bounded context, and therefore what is the size of a microservice if it is a bounded context. According to Fred George, it should be just one entity in essence, and many others have picked up on that. If you actually look at the general guidance for the Lagom framework that Lightbend has just come out with, in essence, they're saying that a bounded context is roughly one entity type. I know that might not be exactly accurate, but in essence, that's what they're calling a bounded context. This is what a bounded context is. This is the size of your bounded context. Ask your ubiquitous language. What is the size of my bounded context? What does that actually mean? What is your ubiquitous language? This language is developed by business experts who carry the vision of what will this product have, why will this product make us competitively, strategically superior to our competition, and it's also shared with the developers on the team. So we put together a group of domain experts and developers, at least one domain expert, probably one, and maybe 3, 4, 5 developers on a team, and they work out what the vision is, what is the domain model, and what does our ubiquitous language hold. And oftentimes, we think in terms of our ubiquitous language being a set of nouns. Developers say, well, it's product. If we're talking in Scrum, an application that helps developers manage Scrum, then it's the nouns. It's the product. It's the backlog. It's the sprints. It's the releases. It's the team. That's our ubiquitous language. But actually, the ubiquitous language is much richer than that. Think of a ubiquitous language as being the linguistics, the language that the team speaks, that are all cohesive. expressions that you can't actually make or state unless you use cohesive expression or terms together. So the terms of your ubiquitous language will be together. So for example, I just used a Scrum application for a bounded context. In this case, our bounded context would have product, backlog item, release, sprint, team, team member, and product owners, sort of as a minimum size of our ubiquitous language. But our ubiquitous language is not limited only to the entities or the aggregates within the microservice. But if you want to see a decent size of a microservice, this is a decent size of a microservice. Therefore, the other parts that are not core, that are not part of that ubiquitous language, belong to a different bounded context. And so in this case, we have issue tracker, which is a different bounded context. We have collaboration, which provides forums and discussions. And we will actually use forums and discussions in the Agile Project Management core context, but they will not be part of that microservice. They will be part of a different microservice. And finally, so that we don't silo our users and the roles that they play, we have a separate microservice, which is the identity and access bounded context, okay? Now, think about those as the practical size of microservices and compare that to how many microservices we would have if we had one entity per microservice. If you count the yellow circles in each of those bounded contexts, it comes out to 35, okay? Is it exactly 35? Maybe it's going to be 40 or 50, but imagine deploying 35 to 50 microservices in order to implement logically the same thing that you have here. So which would you rather deploy? 5 microservices or 35 microservices or 50 microservices? So a microservice as a bounded context is larger than one entity, but it's also much smaller than a monolith and definitely very difficult to turn into a big ball of mud because there just isn't that much to it. On the other hand, it is greater than a single entity. So our ubiquitous language is greater than a single entity. Again, use linguistics to determine what is cohesive within the discussions that we have on a team with our domain experts and our developers. So our ubiquitous language includes entities, it includes commands. Commands are the statement or intent to process some action, and event messages are also part of the ubiquitous language. This is a fact, it's an outcome of a command that has been executed. So your ubiquitous language within a Scrum or Agile Project Management bounded context or microservice would include a product, yes, that receives a command, planned backlog item, and emits backlog item planned out of the product. A backlog item entity receives a defined task command and it emits an event task defined. These are all part of your ubiquitous language, and you should be able to have reasonable discussions with your domain experts about products, about backlog items, and the commands that they receive and the events that they commit. Also, a very, very important aspect of microservices is that each microservice must own its own database schema. So, in the case of our Agile Project Management context, it has its own database, at least one. In fact, it has 2 databases. It has one database that stores all of its events, and it has a different database through which we perform queries. So a query model and a command model. And we'll discuss that a little bit more later. But also those other microservices that we saw before too, the issue tracker, the collaboration context, the identity and access context, and so forth. Each of those also have their own bounded context, or their own databases within their bounded context. So again, we have an event journal. This is one database that holds all the events, all the facts about what has ever happened within the microservice or bounded context. So all events going in, and those events can also go out and become stimulus to other bounded contexts. Then we have our query model, and our query model is the model through which we have optimized queries that in essence are in the shape that the user needs to see on their screen. And overall, this pattern is called CQRS. Perhaps you've heard of it. It stands for Command Query Responsibility Segregation, which is kind of a mysterious name for a very powerful pattern that allows you to query in the form that the user needs to see. And I'm also promoting the use of actors. So actor model and Akka are asynchronous services. So you have service endpoints, you have within the service itself, your entities themselves are actors, and other parts, basically the entire microservice is implemented mostly of actors. And one thing that I want to emphasize with developing microservices as bounded contexts is not to do this. Don't put your brain on acid when you need to integrate with another microservice, and this is what I mean. When you have an incoming request into one microservice, this would be in the upper left-hand corner, this microservice, so an entity receives some stimulus as a command, and the command causes some state mutation or update in your service. Now you need to make another microservice consistent with that. How do you do it? Do you emit a command from your microservice in order to balance the entity in the lower right-hand microservice? That would be the wrong choice, because if there is ever failure, you will have inconsistent models between your microservices or bounded contexts. Now, I already saw some of you shaking your head, obviously no, don't do that. But what I find when I walk in to consult with companies is that this is done all the time, actually. And because of this, organizations hire entire teams of developers just to patch data every day because of intermittent failures between services. And they're also trying to find where did the leak happen, why did something fail, and they're trying to patch the code every day, while the mainstream developers who actually are working on new features of the product, that's actually a different team. So that's a sad situation to be in, but very commonly you'll find this at the root of problems like that. So this is actually something that I agree with that Fred George says. Okay, Fred George says that you should have rapids, rivers, and ponds among your microservices. And actually, the rapids are where you publish all events. So you actually have a place where all of your domain events from all your microservices go into, in essence, a high-performance bus. So, for example, the microservice in the upper left-hand corner produces a domain event. The domain event is part of the ubiquitous language of that bounded context, that microservice. That domain event is then fed to a topic, let's call it all for the sake of illustration. There's a topic out there called all, and this all topic is collecting all domain events from all microservices, and then it's up to each microservice to determine, is this a domain event that I'm interested in? Is it something that I care about? Is it a fact that I need to react to? If it does, then it can react to those domain events. And this requires that your topic of all be on a high-performance bus. This could actually be done through a RESTful kind of interface where topic is taking in new domain events, building them up into atom feeds or event logs, notification logs that are then distributed whenever a consumer pings the domain server or the topic service and says, I need the current state of the event logs. It could be through KAFKA, a very high performance message bus. It could be through RabbitMQ. It's really not my desire to tell you what you should use for this high performance topics message bus, but in essence, you could use a variety of different tools to accomplish that. The rivers are basically where each microservice determines, I'm going to pull this information off of the rapids, I'm going to divert it into my microservice river, and I'm going to consume it there. And typically what happens when you consume a domain event in an interested party microservice, so I am now consuming a domain event that occurred either in my microservice or in another microservice, I'm going to turn that domain event into a command, because there's a difference between a command and a domain event. Again, a domain event is a fact that cannot be denied. You can't deny that a domain event has occurred, that there was some stimulus that occurred in some microservice or bounded context, and this happened, and so we have a fact about that. Whether or not you will actually react to that fact is a determination within your microservice, and therefore you create a command that corresponds to the event that happened, and you have the opportunity to reject the command if that command is inappropriate at that point in time. And one simple example of rejecting a command is if you have already processed, in essence, that domain event before, and you have an idempotency check that says, I'm going to reject this command because I actually have already seen it. So that's just one example. So in essence, what we have is the topics is feeding events to an interested party microservice, and the event is turned into a command which is then produced on the entities. So our entities are always producing or always reacting to commands. The pawns, I believe, are analogous to the aggregate actors themselves, the entities, if you will, the states within your microservices. So we have an incoming command. This command could be produced by a user that is submitting an action request, which is interpreted as a command. It's given to an entity. The entity produces an event. The event ends up in the event log or event journal. And so actors emit events to the rapids. So this same entity that has just received a command emits an event saved to its event journal. The event journal is then read, and the event is put onto an all topics central bus. I just want to make one comment about channel services, that channel services may, in fact, be smaller. Their ubiquitous language may be a bit smaller, and this is what I mean. Let's say that we have a bounded context or microservice that we imagine should have offers detector, resort offers, resort reservation process, which is a process manager, and a member query service. Do those actually have cohesion in a ubiquitous language? Possibly not. We might actually want to model those as separate services where our ubiquitous language is really quite small, and this is where a microservice then would be quite small, because you probably want different services dealing with the reservations and a different service dealing with the actual detection that some user qualifies for a special offer, for example. So, reactive. What is reactive? Reactive is responsive, resilient, elastic, and message-driven. And when I say responsive, I see commonly within the architecture that I am discussing here, benchmark times of an incoming REST request going through the command, the modification, the state modification of the aggregate actor or entity, and the production of a domain event, and then a reply response to that of somewhere between 12 and 20 milliseconds. I'll allow you to judge if that's responsive. I think it is. Resilient. The thing about using actors everywhere is not only that they are responsive and asynchronous and message-driven, but resiliency is something that is afforded actors by nature, because it is the parent of a created actor that intercepts some sort of crash, which in essence is an exception. So if an exception occurs in a child actor, it's not every client that needs to understand how that exception should be dealt with. Instead, it's the parent. That leaves the client to only be concerned with, does the actor that I made a request of respond to me in a certain period of time, or doesn't it? And if it doesn't, I can simply retry the request, and that's all that I need to know, is either it has responded to my request or it hasn't. And then I can retry, whereas the parent is a specialty component that understands every way that an actor might crash and is in perfect condition or position to also understand how that actor should be recovered. Elastic, I'm not going to say much about this, but you can read about great examples with Akka where there's a 2400 node cluster that was deployed on Google Compute Engine. And the good thing about a 2400 node cluster is it only needs to be 2400 nodes if it needs to be 2400 nodes. And if it only needs to be 500 nodes at this point in time, then it can only be 500 nodes. That's what I'm talking about with Elastic. And of course, actors are message-driven. They're message-driven through both the commands, messages incoming, and the messages that are event messages, which end up going through the rapids, processed by other actors and other contexts. So what I wanted to do, and hopefully I've succeeded, is leave about 10 minutes to walk you through how to implement microservices with Scala and Akka. So this is the distributed use case that we're going to walk through in code. We have the Agile Project Management context or microservice in the upper left-hand corner. A create product command comes in as a stimulus to this microservice, and we're going to create a new product based on this stimulus. The product is actually going to produce two domain events. It's going to produce a product created domain event. It is a fact the product was created, but also if the product command, create product command, has in it a request to create a corresponding forum and discussion so that the team that's using this Scrum product can have forum discussions about the product, then we're also going to emit a discussion requested domain event. that domain event, discussion requested, is going to be acknowledged as of interest to the collaboration context. And that collaboration context, when it sees that domain event, will create a command that will cause the forum and discussion to be created in the other microservice or the other bounded context. It will then emit a discussion started domain event, which will go back into the topics, and that is of interest to the Agile Project Management microservice. And as you can see as the fifth step, the discussion started is going back in to that microservice, and that allows that microservice to harmonize the fact that we now have a product with a discussion that was created for it in another microservice. Okay. So let's look first of all at the code example for starting a service. Every microservice should have a way to bootstrap the service or boot the service. So this is actually using Play, the Play framework, and this is using injection, and this specific example is an eager singleton, which allows us to bootstrap when the service is actually being started. And we take care of some common housekeeping things, like we're going to attach to some other services like our quote feeds and so forth. I won't bore you with this, but basically there's a heartbeat that every few seconds we're going to broadcast our microservice interface, our RESTful interface, out to a service registry, and that service registry will then be capable of telling other microservices when they inquire, where does this microservice live, what router is it behind, or whatever. The next step, though, of interest to us is where the product command comes in. So this is a Play controller. Now you could use Akka HTTP for this, but I've chosen to use Play framework, and we simply have a mapping of an incoming URI with a request, a post request to create a new product. The product, the create product method is invoked by Play, and we read some JSON off of the incoming request. And then we create a new product with a unique ID as an actor, and then we dispatch this command, create product, to the product actor. All right? Oh, is it not? I was hoping that would be big enough. Let me see. Oh, sorry. Text, edit. Let's see. Let's hope. Does that work? I hope. And I will maximize the tabs. Okay. So we've got this controller, and this controller is going to create a new actor. And this actor has a unique identity. We're then going to send a command to that actor, a command message saying create product. We then get a future because we're actually using the ask pattern. We get a future, and the future is mapped to a create product result, and the result will, in essence, create a JSON response that puts a location header. So it's using a RESTful approach, which is the product location, and the product location is provided by the result. It's a unique identity, and you'll see this functioning in a moment. Okay, Back to the slides for a second. So that's our service endpoint. Also, what we have possibly behind the controller is a process manager. That is if there is a multi-step process involved in handling a single command. And what I will show you next is in the collaboration context, we have this situation, because what we're going to do is actually create a forum entity and a discussion entity. So it's a two-step process. And so what we do is we have a forum discussion starter actor that is a process manager. This process manager begins its process by taking in a start forum discussion command, and then it creates a command, a forum using the start forum command, and then it uses become, so the actor's context become, to become a listener for that specific forum started event that's going to be emitted from the start forum command, the request for that command. When that forum started event is received by the process manager, then it's going to create a new discussion actor entity and tell that discussion to start a discussion. Then we're going to become a discussion started listener, which is this one, this receive block. And when this receive block receives a discussion started domain event, then we can tell our original sender that this entire process has completed, that the start forum discussion result is the outcome. All right, so that's how you can do at least a process manager within a single microservice. There's also the chance that you need a process manager that spans microservices. That's another topic. Also, we have aggregate actors. In this case, we have our product, which is a persistent actor. So this is using Akka persistence. And this persistent actor takes as a command, so in its receive command block, receives a create product command, and it's going to emit possibly two events. It's definitely going to emit this product created event, and we're going to create a sequence of events, because if the command says that we are requesting a discussion to be created in order to partner with that product, then we're also going to emit a discussion requested event, and then we're going to persist those two domain events, and as an outcome, we're going to update our state based on a product created and a discussion requested, and then we're going to reply to our sender, which in this case is the controller, the create product result. Okay? So all of this is happening asynchronously, and because the controller is working with a future, it is not blocking, but it's actually just ready to receive this, this message when it returns to it. Okay? So that's basically how to implement, or at least the very high level, how to implement an actor aggregate. And now we're going to look at how we implement CQRS in a view. So actually what we have is a timer, a scheduled timer event or message, products, views, projection, tick, and this, for the sake of teaching, only occurs every 2 seconds. It could be much more granular than that in an actual production environment. But basically, every 2 seconds, what we're going to do is use Akka streams through the Akka persistence query library, and we're going to get a materializer and read new domain events that have occurred within our own journal, within our microservice. And then what we're going to do is project each of those new domain events, if they're applicable to this particular product's view, and we're going to project those domain events into the shape and structure of data that we need for the user who may be interested in what this product looks like in terms of its view. And you're going to see how that works in a moment. And then we have the notion of a topics feeder. So similar to the product's view, the feeder is on a recurring basis. And in this case, again, we're operating at every 2 seconds. Again, this is not the kind of timer granularity that you would use in production, but it allows the human eye to detect when things happen when I'm running this demo. But we also have used the Akka persistence query to read the events out, and then what we're going to do is go to that central bus and feed all new domain events to that central bus. And then we have a topics reader. So every microservice has a topics reader, again, that on intervals is reading from the topics, the all topics, any new domain events that it hasn't seen yet, and it's going to dispatch those to a registered topics reader consumer, and that consumer will do a case match on whatever new domain event we're interested in. In this case, we're in the Agile project management context or microservice, and we're interested in the discussion started domain event, and this will allow us to reconcile the product with the domain, with the discussion and forum that's just been created for it. So what I want to do now is go over here to our to a demo, and what I have here, I have the service registry running, so all microservices register with the service registry. I have the central topics service. These are just 2 technical services. Then I have the actual business microservice of the collaboration context, and I have a business microservice of the Agile project management context. And what I want to do is just use a curl command. I'm going to run curl, which I guess you're not seeing too well, and I'm not going to try to teach myself how to zoom this right now, but trust me, you're welcome to come up and see this afterwards. There's plenty of time. But this is a curl command that is requesting a new product to be created in the Agile project management context. Again, just to remind you, this is what we're looking for in the use case. When I execute that command, it's going to cause 2 domain events. One of those domain events is going to flow over to the collaboration context. It's going to create a forum and discussion through that process manager. That discussion started domain event will flow back to the topics. The topics will then feed it to the interested party, which is the Agile project management context. So let's run that, and what you can see here is that a discussion, I apologize for this. I didn't think about the zooming on this from the beginning. But basically, what we have is a domain event that says that a product was created and that a discussion was requested. All right? In the collaboration context, we see the incoming, the reader has just read that a product was created and that a discussion was requested. In the case of the collaboration context, it doesn't care about product created. It still sees it, but it doesn't care about it, so it filters it out. But it is interested in this fact that a discussion was requested, a forum and discussion are created, and then we're going to feed the outcoming or the emitted domain event forum started and discussion started. This is being fed to the all topics. And then, finally, in our Agile project management context, we have the incoming discussion started, event, and even I can't see this. Here it is, here it is. Incoming discussion started. So that kind of terminates the long-running process or the full distributed use case. Is it time? Okay, sorry about that. All right, any questions? I think actually we have time for questions because this is, no? This is not the last session? It's the last session. I think you should be able to ask questions. It's not the last session? Well, I'm a whole 1 minute overtime, so sorry about that. If you would like, come, oh, I need to do the drawing. So, domain-driven design is still... Alexander Vladimits? Okay. Alexander, it's your book.